Good morning, everyone. My name is George Berghorn. I'm at Michigan State University. I'm an assistant professor in the construction management program and the Department of Forestry. And I'd like to talk with you today about some of the work that we're doing around salvaged lumber and its potential use in much higher applications like mass timber materials. So the problem, as we've seen it in the post-industrial Midwest and other parts of the United States, is that there's a large number of abandoned homes. Just in Michigan alone, we have somewhere north of 200,000. This number, of course, is changing every year as cities like Detroit that have a large share of that number enact programs to tackle some of the standing stock of abandoned homes. But we still know that we're above 200,000 abandoned structures in the state of Michigan. But if you then look at other parts of the United States, the Midwest has almost 1.4 million of these abandoned structures, and then nationally we have somewhere closing in on 6 million abandoned structures. And if you look in the second column of the table, there's a large amount of what we believe is potentially salvageable lumber in these structures. And we define potentially salvageable lumber as, first off, structural lumber, so 2x or other dimensional structural lumber. And then we estimate that number in part based on what we believe the average salvageable fraction of that material to be. So we think about 50 to 60% of the material on average is salvageable and suitable for some structural reuse. So again, if we just look at Michigan, we're talking somewhere on the order of over 1 billion board feet of lumber that may be in those 200,000 plus homes that are dispersed across the state's geography. Adding to the challenge or the problem posed by that large amount of abandoned structures is the fact that on an annual basis, we tend to landfill more wood from construction and demolition operations than we harvest from the national forests each year. So there's a tremendous opportunity in terms of the annual lumber that's being handled and then placed into landfill versus what we harvest, from virgin sources. So if we can think about ways to take that virgin or that landfill material, divert it, put it back into some productive use, we may be able to have some pretty significant impact on environmental performance, waste management scenarios in the United States. So if we go back to that original table and say, okay, so we have all these homes, we have all this lumber that's just sort of sitting there that, mostly when these homes get dealt with, they're demolished and the material is landfilled. Let's look at what this amount of lumber actually equates to in more practical terms. So that 1.1 billion board feet of lumber in Michigan is functionally the equivalent of about 219 million end tables, 11 million dining room tables, 5.5 million picnic tables. And so I put these numbers there only to really sort of expose the scale of the problem. This is just the Michigan numbers. Furniture manufacturing is something that we commonly see as a proposed higher value use for this dimensional lumber that is left behind in these homes that could be salvaged. But even if we started looking at furniture use as kind of the most appropriate or the highest and best use of this material, we're talking about furniture production that's on major league industrial scales. And really, again, the reality of how much of this can be made and how much of this can be sold starts to become questionable if we want to treat all of these abandoned structures in some way and capture that material and put it into productive reuse. So we started thinking about industrial scale uses that would consume more of this lumber and consume it in a different way, sort of a non-end user based way. So we looked at mass timber buildings that have been put up across North America, and we said, okay, what if we could make mass timber out of this material? How many such buildings could we build? And so we looked at the Brock Commons, which is a dormitory at the University of British Columbia in Vancouver, 17 stories of timber. So if we took all of that material, turned it into 100% salvaged content, cross-laminated timber and glue lam, you could put up 644 Brock Commons projects. If you mix virgin material with salvage source to make CLT and glulam, that number goes up, right? Maybe it goes up again by another half or another 2/3, depending on the fraction of virgin timber that we use. So this was really the moment where we said, okay, we need to think differently about how to handle this material and where it can go. But there are significant challenges to reuse of this salvage structural lumber. First being code acceptance. All of the lumber grading agencies, or I should say none of the lumber grading agencies, recognize salvaged lumber in any of their grading standards. There has been some academic and industry work that looks at what can be done with salvaged lumber and how does it grade out. And about 10, 12 years ago, there was a paper put out that said, well, if we look at the mechanical properties of salvaged lumber, they're pretty good. So if you take a stick of salvaged lumber and it doesn't have a grade stamp on it, or you don't wish to get it regraded for future structural use, we would just downgrade it one grade on the visual grading scale. So if it graded out as a number 1 visually, then you would grade it as a number 2. So there was some move to try to get this material accepted into code, but save for some academic work, we haven't seen much come of that, particularly except in Oregon. Oregon has now allowed the reuse of salvaged lumber in their residential code. The limitation on what's been done in Oregon, unfortunately, is that it's only related to Doug fir and larch. And again, the idea is that per what's in the code, you can take salvage Doug fir larch and just regrade it as a number 2. So again, it's usable for construction purposes, and it's usable potentially to be made into higher end products. But we're just talking about that Doug fir larch species group. So that's pretty silent on what's going on in eastern and southern species right now. Other challenge to reuse, big challenge to reuse, is the time, cost, efficiency of getting this material and then the supply chain for moving this material once it's salvaged. So we had done a national survey a couple of summers ago of people that are in the business of salvaging lumber, particularly. And we asked them a number of questions. You can see this one here. It's a statement that they could agree or disagree with. The currently available tools for removing fasteners from lumber are adequate to perform this task safely, cost effectively, and efficiently. And you can see that their average score came in just slightly on the disagree side from neutral. And so our group, said, well, this was sort of a resounding meh type of an answer that nobody feels really strongly one way or another about currently available tools for helping to harvest and salvage and prep this material. And when we looked at 2 case study homes just here in Lansing, pretty similar homes, the one on the left was demolished, the one on the right was deconstructed. What we find is that you can demolish a house and fill the foundation in with about 40 worker hours. And that took about a day and a half of total time. But if you deconstruct a home of similar size, you're talking about 260 worker hours, basically half of which goes into the physical deconstruction, the physical removal of the structure. And then about another half of those hours is spent denailing. So just getting nails and fasteners out of the wood so that it's prepped for reuse. So this becomes a major inefficiency, a major bottleneck in the recovery process of the material before we even get into talking about supply chain and things like that. The other issue that frankly has been hampering some of this salvage material or salvage lumber reuse has been the cost of the material by the time you go through all of this handling and all of this prep process. We did a little bit of back of the envelope calculation and found that salvage lumber costs about $833 per 1,000 board feet, and that's just to harvest it, so to collect it from the homes where it exists, and then to transport it to some point of remanufacture or reuse. So if there's remanufacturing, that cost continues to go up from that point. If we look at the normal pricing for virgin material, and I put normal in quotes because we know that wood prices have been anything but normal since COVID-19 hit. But normally in Michigan, stumpage for softwood species is going for about $161 per 1,000 board feet. And then random length lumber futures in the Great Lakes states are going for about $450 per thousand. So that 833 number, which is really just the stumpage, it's not any further prep. That number has just been a non-starter for a lot of different actors that are in this system, and leads to further, uh, the further downplaying or the further restriction on use of this material. But if we look at the lumber futures cost chart that we've seen in the U.S. over about the last 9 months, we know that there was a big spike last fall in lumber prices, and we're seeing that spike happening again as of late last month, with lumber prices pushing above $1,000 per thousand board feet. So if we now start to think about where the pricing is going and how pricing is behaving on softwood lumber, maybe we can start to think about salvage material as a way to dampen some of these big swings in these markets. And so salvage supply becomes almost like a faucet that can be turned on, material that can be brought into the market to sort of dampen some of these price effects, because frankly, these prices are having a rather chilling effect on the home building industry right. The other piece that this so far has ignored is whether or not there's carbon valuation that can be attached to these materials. So if we start thinking about salvaged lumber and moving salvaged lumber through these higher use value chains, where we're moving them into long-term or long-lived wood products, and now you're going to be storing carbon in those long-lived wood products for a long period of time as well. If we got into some sort of carbon regulatory scenario, carbon credit trading scenario, there may be additional value for this material to again offset some of those higher preparation costs for the material. So we've done some work at MSU towards solving some of these challenges that were raised. The first is that we've been looking at mechanical properties of southern and eastern spruce pine fir species. So we've been taking some material from some homes that were deconstructed in Michigan. And again, it was primarily southern and eastern species. We've just been grouping it because of the mix that we've been getting into the SPF category. And you can see here that based on modulus of elasticity, where normally you're looking for numbers somewhere in the 1.2, 1.3 million to look at what might grade out reasonably well for future use as construction lumber, you can see that in this group of I think this was 68 samples, really 67 have hit that mark. One sample did not. So from the first pass, we looked at our data and we said, this material, there's something to it in terms of its suitability for future use in these higher value applications. And then we looked at specifically the entry grades for making CLT and for glulam. And we found that in 5 of the 6 commonly encountered entry grades for CLT, over 90% of our samples that we've run pass to be used as feedstock for manufacturing CLT. And then we looked at glulam entry grades for laminations. And again, we found that in one specific grade of glulam, 2 of the 4 laminations that are required to make those glulams, again, we had greater than 90% of our samples pass. So now our next step is to actually make panels to make glulams and start to test those structurally. But right now, at least the entry grades of the material appear promising to be used in that application down the line. The other side of the work that we've been doing is getting at some of that time, cost, efficiency, and supply chain concerns. So we've been looking at where automation can start to come into this process. And so we've really been focusing on scanning and sorting of material and how automation can improve efficiency on that side of the operation. And so we've had some students that have developed requirements analyses by taking sort of the human activity to scan and sort and prep salvaged lumber and turn it into a series of computer instructions. So we have that going on. We've then done some imaging work to look at, can we detect nails, screws, any other kind of fastener, even when they're buried inside of the lumber. So when there's no obvious indicator on the surface of these materials. We've also been asked through that same national survey, could we do a better job of helping to identify surface contaminants like lead-based paint? Could we develop a system that could help visually grade lumber sort of in a more automated fashion? Could we dimension it? And then could we identify other damage? So things like check splits, rot, fire damage, insect damage. And then ultimately, could we cut material to length and width based on sort of understanding what the nature and the quality of the material looks like, and then tag it and inventory it with its requisite properties that were discovered through that scanning and sorting process. So we've been analyzing some imaging options. This was all done with CT scanning, obviously not really cost effective, not something that's easily deployable to multiple locations. But again, we were just playing around with, what imaging options exist, what imaging options can give us in terms of these requirements. And so this was kind of a first pass looking at CT. We're really settling in on things like computer vision to help us instead with some of this operation. And then as we move out of that scan and sort, so we're at the point now where we're looking to make some prototypes, and we're looking for some funding from external sources, from some incubator sources at MSU and other places to make a functioning prototype. And once we move out of that scan and sort operation, then we can also start thinking about how to automate or capture some of the supply chain information that's going to be important as we try to deploy this material. So if we begin with a deconstruction operation on the left side, we know that in some cases the contractor that does the deconstruction will retain material. And we know that in other cases, material will just be deconstructed and then transported to sort of a central hub, like a MRF type of a facility for construction and demolition debris. So you could, from the same project, have two pathways that the material is taking through the supply chain. So if it goes to that centralized hub or MRF type scenario, we're looking at what it would take to then create a digital platform for those materials. And based on the information coming from that scan and sort operation, you then would know what of this material is viable for construction application directly, for use as an energy or chemical feedstock in a biorefinery type of application, or a manufacturing feedstock to go back into, again, making glulam, CLT, higher value products. And then what products exist at a consumer scale that could just be sold directly to consumers. So if those first three gray boxes are more like B2B type connections, that last one would be direct sale back to consumers. For material that's retained internally by contractors, as well as that externally facing material, the idea is that we then create this network of what's available. End users can tap into these networks based on what they need to see what's available, where is it, they can arrange shipping for those materials, et cetera, with the end goal of just redeploying this material ultimately. So whether it's going to be redeployed directly, direct reuse, or redeployed in some remanufacturing scenario, this is other work that we're starting to put some thought behind at MSU right now. So with that, I thank you very much for your time. Would very much welcome you to contact me. My email address is here if you have questions, if there's things you heard that you want to discuss in greater detail, if there's things that you just from your experience don't think are viable, all feedback is welcome. So please don't hesitate to reach out, but I do appreciate your time and this opportunity to sit here and present this work with you today. Thanks so much and have a great summit.